Page 9 of Eulers and complex numbers for MHL, chapter 16. The Cartesian form of Z, we can look at this diagram and we could call it x plus I, y, right? Polar form of Z equals R cis theta. Cis theta. Where R equals the square root of x squared plus y squared. And the tangent of theta is equal to y divided by z. And the sine of theta is equal to y divided by r. And cosine of theta is x divided by r. All according to this diagram here. Use your calculator to convert to Cartesian form. Oh, calculator, okay. Okay, so let's plug this into the calculator. First thing you need to do is make sure you're in the right mode. Make sure that your mode is radians, and then normally it starts out in real. Why don't you change that to a plus bi form for imaginary numbers. And we're going to type this in here. It's kind of hard to type in cis. Let's see. Square root of 3, parentheses, cosine 2.5187, close parentheses, plus I times sine 2.5187, close parentheses, close parentheses. So that gives me negative 1.41 plus 1.01 I. 1.01? No, 1.05 I. Now let's look at C. So C is 2.83649 parentheses cosine of negative 2.68432 close parentheses plus I sine negative 2.68432 close parentheses, enter. So this will be negative 2.55 minus 1.25 I. Actually, when I went back and checked the first number, it is 1.01, not 1.05. I was right the first time. Okay, all right. Number 2, use your calculator to convert to polar form, 3 minus 4i. There's a couple ways to do this. Let me show you the easy way first. So you'd go into mode, and you say, I would like to have Euler's form, which we're going to do next page, okay? And then I'm going to type in 3 minus 4i. Enter, and it gives me the Euler's form, okay? But let's do this separately. We'll do the modulus, and then we'll do the argument. So 3 minus 4i, we're going to draw a right triangle, which has plus 3 here, and plus 3 and minus 4. So it would be 3 to the right and 4 down. Do you know the famous 3, 4, 5 triangle that you need to know for your SATs? 3 squared plus 4 squared equals 5 squared, right? 9 plus 16 is 25. So we already know that the modulus is 5 without even doing any calculation. Then we need to find the angle here. And we could find the angle there by doing either sine of theta is equal to 4/5 or cosine of theta is 3/5. Let's do inverse sine of 4/5. And then we'll take the negative of that. So it'll be negative 0.927. So theta equals negative 0.927 in radians. And that will be cis that. Okay? And you can check that. That's what we got in Euler's form. Let's do number 3. Remember, surd means to leave everything in radicals. So number 3, add the following using a plus bi surd form and convert your answer to polar form. So let's leave exact expressions for sines and cosines of pi over 4 and special angles, okay? So 3 cis pi over 4 would be 3 times cosine of pi over 4 is square root of 2 over 2. Sine of pi over 4 is also square root of 2 over 2. And cosine of negative 3/4, negative 3/4 is like that triangle right there, okay? Negative 3/4 is that. So this would, the cosine of that angle would be negative square root of 2 over 2. And the sine of this angle would also be negative square root of 2 over 2. Okay? Now we're going to add everything together. So first of all, we got 3 of these minus 1 of those. So that would be 2 of those. Then we got 3 of these minus 1 of these. And that would be 2 of those. So in the end, we have, let's cancel out here, we end up with square root of 2 plus I times square root of 2. If we drew that triangle, it would be at 45 degrees, right? Because both sides are square root of 2. And the hypotenuse of this triangle would be square root of 2 squared plus square root of 2 squared. Square root of that would be 2. So the cis theta form, or the polar form, would be 2 cis pi over 4. Last one. Use the sum and product of roots to find the real quadratic equation with roots of 2 cis pi, 2 pi over 3 and 2 cis 4 pi over 3. So assuming that these two are the roots, we're going to first find the sum of the roots, and then we're going to find the product of the roots. So if we add those together, let's convert them into a plus bi form, shall we? So like the first one is 2 pi over 3, which is that angle right there. And the hypotenuse is 2. So the x component would be negative 1, and the y component would be negative, no, not negative, positive square root of 3. And I would write that out by writing negative 1 plus I times square root of 3. And 2 cis 4 pi over 3, 4 pi over 3 is this angle right here. And that would mean that this is negative 1 and this is negative square root of 3. So I would say, if I was adding them together, I would say, okay, minus 1 minus I square root of 3. And if you add those together, you would get that these cancel each other out. And so you would end up with negative 2 as the sum. What if you're going to do the product of these two roots? If you do the product of these two roots, it's easier if you just keep them in polar form. So you would have 2 cis 2 pi over 3 times 2 cis 4 pi over 3. And you would multiply the two moduli together, and you would get 4. And you would add the two arguments together, and you would get 2 pi over 3 plus 4 pi over 3 is equal to 6 pi over 3, which is equal to 2 pi. And 2 pi is the same thing as 0, because 2 pi is like 360 degrees, which is also 0 degrees in the unit circle. So basically that is equal to real number 4. And if we wanted to put this in a quadratic, then we would say it's equivalent to x squared minus, and the sum of the roots becomes the negative of the sum of the roots becomes the b coefficient, and the c coefficient is the product of the roots. So our, and then we would leave a here because we don't know what the a coefficient is. So we would have x squared plus 2x plus 4 as the real quadratic equations, a set of real quadratic equations that have the roots, these two roots. And one thing, a cannot be 0. Okay? All right, that's it for this page.